Hey guys, just before we get into the lesson, I just want to let you know that you can catch these live on YouTube every Tuesday from 6 PM till 7 PM in the UK time. And that means you can be more interactive, you can ask your questions and they'll be answered. Okay, so without further ado, let's get into the lesson. Okay, welcome back to the third of my kind of free tuition lessons on YouTube. Today, as per request, we're going to start going through trigonometry. Okay, so just so you know that if you are kind of either commenting or in the chat, you can request different topics. So with trigonometry, essentially, it's what we use when we have a right-angled triangle. Okay, so you may know that if we have two sides, let's say 4 and 2, we can work out whatever the x side is by using Pythagoras, right? So x squared equals 4 squared plus 2 squared. And then just go on and we can work it out. That's all well and good, but what if we want to work out an angle? Or what if we have an angle, let's say 30 degrees, and we have one side and we want to work out any of the other two sides? What can we do then? Well, that's when we use something called trigonometry. And in terms of trigonometry, there are three kind of things that you may have seen on your calculator. We have sine, we have cos, and we have tan. So if you have a look at your calculators, you should see sine, cos and tan buttons somewhere on your calculator. So for mine, it's just over there. And that's what we're going to be using. So you may have seen SOHCAHTOA before as well. So just as a reminder, let's go through it. So we have these sine, coses and tans, but we need to know when we can use them. Okay, so we can use them, or kind of which ones we use in a given situation. So the SO part stands for stands for sine equals opposite over hypotenuse. The ca part, so you can use sine opposite hypotenuse. The ca stands for cos equals adjacent over hypotenuse. Okay, and normally we put like the angle sign here. Okay, and lastly we have TOA, which you can probably guess gives me tan theta. The O again stands for opposite, and the A stands for adjacent. So knowing this, you can actually do all trigonometry questions. Okay, except for the sine rule and cosine rule, which we'll come on to next week. But we can basically work out a bunch of different stuff from that. But what we need to do first is we need to be able to label our triangles. So I've used these words adjacent, hypotenuse, and opposite, but I don't actually know what those mean yet. So what I'm going to do is I'm going to draw a very generic looking triangle. It's going to be right angled because keep in mind we can only use this only for right angled triangles. Okay, that's the only time we can use it. And let's say our angle that we get given, okay, we use this kind of Greek theta sign, is here. So how will I label my sides? Well, this is the really important thing you need to be able to do. So let's start off with the opposite, because it's the first one here. The opposite side is the side that's opposite the angle. So it's always going to be the one that is directly opposite the angle. So I can also just write this as an O. Okay. The adjacent one is the one that's adjacent, so touching the angle. However, we'll come back to the adjacent because there's something slightly tricky. The next one you want to label, so you first label the opposite. Now we're going to label the hypotenuse. Now the hypotenuse is the longest side in a triangle. So how will I know? Well, you can look, but that's not exactly very mathematical. But it's always going to be opposite the right angle is the hypotenuse. Okay. Now the adjacent is just the only other one that is left. Okay, so hypotenuse we sometimes just label it as H. And the adjacent is the last one left, right? The triangle is made of 3 sides and we have 3 names. Okay. So that's where that comes from. Okay. Now, if I tried it again, let's draw another triangle. Okay, and I'm going to start giving it some numbers, okay? We have 20 degrees here. Okay, we have 3 centimeters. Let's label up our sides. Well, again, we start with the opposite. So what I'm going to do is draw a dotted line going directly opposite my angle, and I hit the 3 centimeter side, which is my O for opposite. The hypotenuse is always opposite the right angle, so I'm going to put a H on the opposite side, and therefore the A is the one next to it. That's as easy as it is. Now, of course, we haven't actually done any maths yet, okay? We just labelled the triangle, but labelling the triangle is the first step. If you get the first step wrong, you get the rest of the question wrong. So it's really, really important that you remember this. Opposite the right angle, hypotenuse. Opposite the angle you're given, because again, keep in mind, if I give you a different angle here of, let's say, 30 degrees, that's impossible, but anyways, my opposite and adjacent switch positions. So it's opposite the angle you're given or that you want to use. Okay? In terms of which one you want to use, you can use any one you want. Just make sure you've labelled your triangle properly. Okay. So, assuming that makes sense, let's go on to do an example here. Okay, so if I label this question number 1, let's bring question number 1 up here. So again, what's the first step? The first step is to label your sides. So what I do is I draw a dotted line going from the angle they gave me, and that's my opposite side because it's opposite the angle that I've been given. The next I label the hypotenuse. Well, okay, I do this. Again, a dotted line going from the right angle means that this side is the hypotenuse. The last side has to be the adjacent. Okay, so now we've labelled up our opposite, hypotenuse and adjacent respectively. We now need to work out what, well, let's see what the question's asking us. It's asking us what the value of x is. In other words, we need to find, so we're finding h, which is the hypotenuse. Okay? So in terms of how we do that, we look up here at our SOHCAHTOA, and we look at what we have and what we want. Okay? So we want to find h, and we have O, which means we want to use O and H. So which one of these three has O and H in it? Well, it's SO has O and H in it. So we're going to be using sine theta equals opposite, which, so op over hypotenuse. Okay. The other way to do this is to use a formula triangle. So we're going to have sine in the bottom. Here we have hypotenuse, and above we have opposite. And if we have this triangle, we can use that to work it out the answer as well. So now if we want to find the hypotenuse, we need to rearrange this formula. Okay, or what you can do is if you cover up the hype part of this, we get that our value is h is equal to the opposite over sine of the angle. Okay, because again, if we covered that up, so again, you can just put your hand on your screen, cover that up, you get opposite over sine. So that's going to be, the opposite side is 20 centimeters divided by sine, open bracket, 35. And all you do is you'd enter that into your calculator. Okay, so on your calculator, press the fraction button first, 20 on top, then press the down arrow to go to the next line. And if you find the sin button, S-I-N, press it. It opens a bracket for you. You type 35 and then just close the bracket. You need to make sure you close the bracket, otherwise bad things can happen. Press equals, and we get quite a long number, but it's 34.9 if I do it to 3 significant figures. So the full answer is 34.8689. Okay. If you want to do it with rearranging instead, all you need to do is, if you make this into letters, you have sine theta equals O over H. Rearrange for H, times both sides by H, you get H sine theta equals O. Then divide by sine theta, you get h is equal to opposite over sine theta, which is the exact same equation that we got with the formula triangle. So there's no biggie there at all. Okay, so I think that should be okay for question 1, but let's have a look at question 2 to see if we can practice what we've learned. First step, you need to label your sides. So draw a dotted line going from the angle they give you, and that is going to be your opposite, because it's opposite the angle they give you. You draw a dotted line going directly opposite the right angle, and that's going to be your hypotenuse. Whatever's left is your adjacent. So in this sense, in this case, we want O, and we have A. So which one of my 3 things here has O and A in it? Well, it's not this one, that's OH, that's AH, but that's O and A, it's tan. So what we're going to be using is TOA, which is tan theta equals opposite over adjacent. Again, if you want this as a formula triangle, you have O, A, and tan. It's a very interesting triangle I've just drawn. Okay. Now, which one do we want? Well, we need to cover up the O, right? Or we need to rearrange the O for O by timesing both sides by A, which means we have A tan theta equals O. If we cover this up, we just have that O is equal to A times tan theta. It's the exact same thing. Rearranging or the formula triangles works the exact same way. And then all we need to do is substitute it in. So O is equal to, what is A? It's 11. And then you can put the times sign if you want, but you don't need it. So if you want, I'll ignore the times sign for now. And that's tan, open bracket, 42 degrees, close bracket. Type that into your calculator. So 11 tan 42. Again, exactly as it appears. I didn't put the times sign, but you're more than welcome to. And you get 9.90 to 3 significant figures. Okay. Give you a second just to work through that, make sure that makes sense. Okay. So that was for question number 2. For next week, I will space out the questions a bit more. So just cut up the pictures and move them around a bit. I'd recommend, if you want to go back and kind of write down the questions just as examples, if you need to do revision or anything, that would be a good idea. But now let's do question number 3. Once again, what do I need to do? The angle I want, so in this case they haven't given me what the angle is, but this is the angle I want. The side opposite is the opposite side. Go dotted line across from the right angle, that's your hypotenuse, and the one that's left is adjacent. Okay, so this is interesting because I want x. I want the angle, so if you want, you can call it theta or x. And we have A and H. So once again, go back to this. Which one has A and H in it? It's K. Down. So we're going to be using K. In other words, we have cos theta equals A over H. Now this is where things get a bit more interesting. Because we don't want cos theta, we want theta or x, whatever you want to call it. So what we need to do is we need to do something called the inverse cos. So we're going to actually work out, if I replace, or just leave it like that, we're going to be typing this into our calculator. Because we're working out an angle. Whenever you're working out an angle, you're going to be doing cos to the -1. Now before you panic, Okay, if you look at your calculator and you look where cosine is, where cos is, if you can you see just above it in a different coloured text, it has cos to the minus 1. The way you get that is you press shift or the same colour button. So in my case, shift is yellow and the cos to the minus 1 is yellow. I press shift, cos, and that gives me cos to the minus 1. That's all you have to do. So theta. Adjacent was 16. Hypotenuse is 24 equals. And again, I'm putting the exact same thing in my calculator. So again, the cos to the minus 1 comes from doing shift cos. Okay, so if you have a Casio, it's going to be shift. Any other calculator, look what the color of the cos minus 1 is and find the button that corresponds to that. It'd be shift or alpha or function. Equals, and we get 48.2 degrees to 3 significant figures. Not too bad. Okay. Going on to question 4. Once again, we start by labelling the sides. So opposite the angle we want or are given is going to be your opposite. Opposite the right angle is going to be the hypotenuse. And then the last side is going to be your adjacent. Okay? That's it. Now let's have a look at what we want / have. We want x or theta, whatever you want to call it. And we have the opposite and the adjacent. Well, let's go back up. O and A appear in the tan formula, so TOA. Opposite over adjacent. So you can probably guess already what's going to happen. Excuse me. So, looking at the first part, when we had cos theta and we wanted an angle, we put cos to the minus 1. When we have tan theta and we want an angle, we do tan to the minus 1. Exact same thing. So I'm going to write this all down, and again, if you look at your calculator, opposite is 15, adjacent is 11. Look at your calculator, where it says tan, in a different colour, it'll also say tan to the minus 1, so you go shift tan. Opposite is 15, 11 is the adjacent, so we have 53.7 degrees. Again, to 3 significant figures. And that should be for that answer. Give me a second just to make sure you're okay with that. Okay. Let's go on to question 5. And once again, we're doing the same thing. Okay? Start at your angle, draw a line going opposite. That is going to be your opposite side. Look at the right angle, dotted line, that's your hypotenuse. The one that's left is your adjacent. Now again, we have an angle and we have adjacent, and we want, what does it say we want? The length AB, which is the opposite side. Okay, so if we're looking at O and A in this case, let's go back up to our triangles. You have SOHCAHTOA. O and A is part of the TOA name. Okay? So we're going to be using TOA, which is tan theta equals opposite over adjacent, or again, if you want to use the formula triangles, you can. Okay, and we want O, so if we cover up O, or again, multiply by both sides by A, we get A tan theta. Right, both ways we do it. So if we sub that in, so that's O equals, and that'll be O equals. So if we substitute that in, adjacent was 20, and then theta was 35 degrees. So 20 tan 35. So again, we're not doing the inverse tan. We get 14 to 3SF. That's it. Technically, we should put centimeters here as well. Hopefully that is okay. Okay, so let's keep going. It's going to get a bit more tricky shortly because, again, this is the most basic that they can give you. If you look, these are only 2-mark questions so far. Look at the next few, they go 3, 4, and they can even have 6-mark questions. So these can get a lot more tricky. So if you have any questions, make sure you ask them now. Because again, it's going to be kind of assumed later on. Assume that you are okay with this. Okay, so let's keep going. So once again, we need to label our side. This is the first step for every human being that does trigonometry. Look at the angle they give you or you want. Draw a dotted line going across from it, and that is your opposite side. If you draw a dotted line going across from the right angle, that is your hypotenuse. Whatever's left is your adjacent. Nice and easy. So what we're going to do here is, if we have a look at what we want and what we have, oh, I didn't even label the question, my bad. So let's put 6 here and here. So what do we want? Or sorry, what do we have first? So we have an angle and we have the hypotenuse. And what do we want? Well, it says calculate the length AB. This is AB and I've labelled it A. Okay? So that's what I want so far. So if I have theta and h and I want A, let's scroll back up to see which one has A and h in it. So no, this one has A and h in it. Ka. So let's write Ka. And that is cos theta equals adjacent over hypotenuse. Okay? So if you want it as a formula triangle, you can put the A on top, cos here, h here. Up to you which method you want to use. I personally prefer rearranging, but that's because I'm a nerd. And we want A. So if I cover up A, what am I left with? Or if I want A here, I'm going to multiply both sides by h to get h cos theta equals A. If I cover this up, I also get A equals h cos theta. It's the same thing for both ways, okay? So, now all I need to do is substitute in what they've given me. So h cos theta. Well, h is 15, so 15. And then we have cos, and what's our theta? It's whatever angle they've given us, or the one we want, which in this case is 42. And again, make sure this is in brackets, equals A, and again it's the same for both. Type it into a calculator, 15 cos 42. Again, it doesn't matter if you put a time sign between the 15 and the cos or not, whichever way, it's fine. And to three significant figures, it's 11.1 centimeters. For next time, I'm going to actually pay for a virtual calculator. So I actually had one before, but the license ran out, which was fun, and I didn't realise that until I was about to start the lesson. So that's a bit of lack of preparation on my part. But for next week, we're going to be able to see this calculator on screen. So if you're unsure now, in the next lesson, I'll be able to do it step by step on a calculator itself. But this will be our answer for part 6. Okay. Okay, just give you a few moments just to make sure that's all okay before we go on to the harder and more fun questions. Okay, so what I'm going to do is remove the last two parts of this for now, just so we can properly have a look at this question. So they give us a trapezium instead of a triangle, so you might think, well, hang on a minute, I thought we could only use it for right angle triangles. Well, you can make a right angle triangle from this, right? Hypothetically, if one wanted to, if I drew a straight-ish line along here, would this top thing be a right angle triangle? Yeah, it would. Okay? So the question is, how would you know this in real life, right? Like if this was just an exam question and it wasn't a trigonometry lesson, how would you know? Well, if we have a look, it says work out the size of the angle BAD. So something that I've noticed a few people kind of get stuck on is the fact that they aren't 100% sure, just give myself some space, they aren't 100% sure which angle they're talking about, right? So here's an easy way to tell. The angle they're talking about is always the letter in the middle. Okay, so if you find the letter in the middle, that's A. And it's made up of sides B to A, so this 4 meters, and A to D. So what's the, oh God, I'm sorry for my handwriting. What's the angle made up from line AB and AD? It's this whole angle here. So if you notice, it's made up of 2 parts. If I write this out here, we have a rectangle, right? Where this is B, A. There's no letter on this side, C here. And there is a triangle part on top. If I separate that out a bit, where this is also A and that's D. So the angle they want is this angle plus this angle. Okay? Give you a second to digest the true genius of what I just did. So if I label some of the sides as well, make it nice and neat, and 15 meters for now. If you have a look, I hope that makes sense. So all I've done is I've basically cut off a triangle off the top, but the total angle is this right angle here. So we already know what that is. That's 90 degrees. That's baby stuff. Plus whatever this angle is here. That's not baby stuff. So my question to you, and this is a right angle triangle because it is, right? It tells me here. So this length here should still be 15 meters, right? So go back to the original question. There's no difference between the length of BC and the length from A to there. No difference. Now, what is this length here? Well, I know that from here to here is 4 meters because this other side's 4 meters. And the total length is 6, which means this must be 2 meters. Any questions? Okay. Assume that's okay. We're going to just cut off that part. So now you can probably see where trigonometry is going to come into play. Right? I now have a right angle triangle and I want an angle. So what's the first step? Label your sides. Draw a dotted line going straight across from the angle we want. That is your opposite. Dotted line from the right angle gives me my hypotenuse. The other thing is the adjacent. So I have O and A, and I want theta. So O and A, let's go all the way back up to the top of the document. O and A is tan. There we are. So we have TOA here, which is tan theta equals op over adjacent. Do you remember what we do when we're looking for an angle? We have to just do the inverse, which again, we should be fine with. So theta equals tan inverse. Make sure you sub in your numbers correctly too. Opposite is 2. Adjacent is 15 in this case. And then if you're doing the tan inverse, you have, again, if you look above your tan button, there is like a different colored tan inverse. You just need to press shift and press that button. And that gives me an answer of, it says give your answer to 1 decimal place, so 7.6 degrees. The full answer is 7.594643369. And that's it. Not too bad. Is that the answer though? Nope. Keep in mind BAD is equal to the right angle 90 plus the angle we just worked out. So in total it's 97.6 degrees to 1 decimal place. So you can probably see exactly where students lose the final mark because they think that this is the answer. Read the question. It's the whole angle. Okay? So if you slipped up on that bit, that should give you some motivation to make sure you're reading the question extremely carefully. Okay. Let's go to the next one. So, this is a weird looking shape, some kind of quadrilateral. It's question 8. And we don't actually need to break this up if we don't want to. This can be done normally. We want to find the value of x. Let's have a look at what we have. Okay. And if you have a look at the right-hand triangle, we have no information whatsoever, which sucks. However, can we work out some information? So what do we need to work out x? So to find x, if we put question A up here, to find x, I need another side, right? So either this one or this one. Because logically speaking, right, if I want to use trigonometry, I need a side and an angle, or I need two sides. At this point, I have just an angle, which is completely worthless to me. So I need another side. So the question is, can I work out this top side? No, I don't think so. Can I work out this side? Well, I have two sides of a right angled triangle and I want to work out the third. So if I call this, so let's actually label it up first, right? Dot, 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 dot. This side is my opposite side, so it's already an O, funnily enough. Opposite the right angle is my hypotenuse, and this is the adjacent. So to find O, use Pythagoras. And in this question here, what are my sides? Well, this is my hypotenuse because it's opposite the right angle. So to work out the missing side O, what I'm going to do is do the square root of 20 squared minus 16 squared. And the reason why I'm doing it that way is because I don't... step back. Normally, you add the two smaller sides together and then square root them. But if I have the biggest side, I subtract them instead. Okay. So I hope that makes sense. So now if I wanted to work out, sorry, that's not O squared. I made a mistake there. If you sub into your calculator 20 squared minus 16 squared, right, again, sub it in, normal. I get 12 centimeters. So now I have opposite, I want hypotenuse, I have an angle. So if we're looking for, so O and H, is sine. So sine theta equals, or again, if you want the triangle, again, I'd recommend learning the algebra, especially if you plan on doing A-level maths, or even doing any kind of science at A-level. But yeah, if not, it's totally fine. What do we want? We want H, so cover up H, and my equation now becomes H equals opposite over sine theta. To do it this way, you'd have to times and divide around, but it's the same thing. And we get H is equal to opposite, which was 12, over sine 25 in brackets, which says to one decimal place, so we'll leave it to one decimal place. 28.4. And don't forget your units, which in this case is centimeters. That's a 4-mark question. Should take you 4 minutes, and I know it's taken me more than 4 minutes to explain it. But in an exam, I reckon you guys could do that much faster. Much, much, much faster. Okay. And then we have one more question. Yeah. And if no one else has any questions in the chat, then I won't go on much further, but there are a few kind of announcements we can make. Okay. Oops. So what I'll do is I'll drag this. Oops. Okay, so I'm just thinking. Okay, got a bit more to do. So, this question, work out the size of angle BCD. So remember, let's mark the C, we're looking at this thing here. And it's made up of sides BC and CD. So we're looking for this angle here, which let's call it... No, let's not call it X. We use theta, because we're men. And we need to work out the size of the angle. Okay. So, once again, right, to find this angle, I need two sides. Right, so if I label the sides I've got so far, that's the opposite, that's the hypotenuse, this is the adjacent. How many sides do I know? 1. I need 2. Which one can I work out? Well, if we look over here on this side of the board here, I could work out this length here and use it to work out this length here, which I'll call y. Or you can leave it as adjacent. To do that, we need to label this up as well. So this is the opposite, this is the hypotenuse, and this is the adjacent. So if we speed up a little bit now that I think we've got a bit more comfortable, we have, or let's say, we want opposite and adjacent. If you remember that, that is TOA, right? So if we write that out, so adjacent, and bear through 1 second. Again, we want the adjacent, so cover up the adjacent. So adjacent is equal to the opposite over tan theta. So it equals 9 over tan 37. So again, let's do this. 9 over tan 37 gives me 11.9 centimeters. So if I know that this side's 11.9 centimeters, then this other side should be 22 minus 11.9 centimeters, which is 10.1 centimeters. Okay? So now I have my adjacent for, so if we call this triangle 2, this triangle 1, I have the opposite and the adjacent, and I want the angle. So I'm going to be doing tan theta equals opposite over adjacent, so we're going to be taking the tan inverse. Opposite is 9, the adjacent is 10.1, so (41.7 degrees). That's probably the hardest question we did so far. So if you understand that, then you're in a really, really good place for the kind of GCSE section of trigonometry in terms of the basic trigonometry. Because just like everything in maths, it gets worse. So what we'll briefly start with today is something called the sine rule. Okay? Actually, we may want to come on to that tomorrow, just for the sake of time. So we start this with SOHCAHTOA. We'll save that as that. The reason for that is the sine rule might take a bit of time. So if we just say that this lesson was SOHCAHTOA, we can reason that we need to continue from this, because I don't think we have time to really go through the sine rule as well. Just because it's a whole new concept and we only have 15 minutes left. So I think we won't do that today. Okay, so in terms of these lessons, again, thank you for everyone that's joining them and kind of watching them live. It's better for you if you watch it live, because you can message me, you can say if you're stuck, you can ask for help, etc. You can give me feedback, you can also ask for specific topics. But I do read all the comments on YouTube, so if you're ever stuck and you're watching this after it's been uploaded, then please make sure that you are kind of leaving comments and suggestions and everything like that. But overall, I think we'll leave it there for today, and tomorrow we'll definitely do the sine rule stuff. But just before we finish up, does anyone want to Let me know if there are anything you want me to go through, or if you've joined late and you want me to go over something. I don't mind doing that for the next 15 minutes. Okay, so just making a note. Okay, well, if that's the case and everyone's okay, then I hope you will have a wonderful evening, and I'll look forward to seeing you in the next one. Thank you very much.